I know what you're thinking. That looks like it should be condemned. It's not in good shape, agreed, but the owner is very attached to it. It's a daily driver. It's had some hard knocks, and as you can see, the dial has gone all out of alignment. Now, this is a fairly common issue with watch dials. They generally have a couple of pins attached to the underside of the dial, and we call these dial feet. And these are the means for the dial to be secured to the main watch movement. Now, sometimes this is with screws, or in this case, they allow for the dial to be friction fitted to the movement. But the problem is that these dial feet are generally, well, they're quite thin in diameter. They're quite often less than a millimeter, and as a result they can snap off fairly easily if they're not handled correctly, or if the watch has received a shock, for example. And this is what we can see here. The dial feet have broken away from the watch dial, and of course the dial has shifted position as a result. So here, with the dial removed, we can see that this used to be fitted with two dial feet, and they have both severed off, and this should make for an interesting video as we're going to explore 3 different ways of repairing this dial, and we'll get this watch back in working order as a result. Now, the first method for repairing this dial I only really mention because, well, it's a quick and dirty approach, but I'm not really recommending it, and this is the use of dial stickers. Now, these are available from watch material suppliers and they can get the job done, but I'd consider this method to be problematic, and I'd go so far as to say that it falls into the realm of bad practice. Now, if you are British and you watched Blue Peter as a kid, then you'll definitely be familiar with sticky back tape, and basically these are simply adhesive stickers that allow you to secure the dial to the movement. Now, I personally don't like using these as they may not allow the dial to sit completely flush to the movement, and therefore the dial will be raised up and the hands, once refitted, may end up touching the dial unless adjusted. Now, I've also seen in the past that the dial is not fully secure when using these stickers and may shift position under some circumstances. Now, in short, my advice is to avoid dial stickers. And next up, we have replacement dial feet. Now, again, these are provided by most watch material suppliers. These are available in several sizes, which can be chosen based on the size of the broken dial foot that you're replacing. Now, these are an excellent choice as they can be adhered to the dial with an epoxy, and because of the large plate, there's plenty of surface for the adhesive to bond well. Now, I personally like using these, and I can recommend their use. However, to get the best result, the dial should be prepared using a special tool, and we'll demonstrate that shortly. And the final method that we shall be covering here today is to use heat and solder, and this is something I've generally shied away from in all the years that I've been repairing watches, as heat has the potential to do bad things to watch dials. However, as you can see here, we've obtained a dedicated watch dial soldering machine. It says it there, look, watch dial feet soldering machine. Now, this method is different from using a soldering iron or an open flame to melt the solder. It uses electricity to generate bursts of heat, which is highly concentrated to one area and for a very short amount of time, so as to reduce the risk of damage to very sensitive dial surfaces. Now, to my knowledge, watch material and tool suppliers do not usually carry these machines. I guess they do involve the user potentially being exposed to some quite high electrical currents, and therefore health and safety is a major factor, I suspect. With that being said, if you are considering one of these machines for your workshop, then you should know that, as with many other forms of welding, there is potential for serious injury, and so obviously be careful. Now, I purchased this unit on eBay and I was prepared to take a risk. Machines like this from independent sellers, I'm pretty sure will not be government approved for health and safety, and so I'll just say again, you should research and you should know the risks. Now, okay, we'll get back to the soldering soon. Let's first take a look at how the pre-manufactured dial feet are fitted. Now here we have a relatively inexpensive dial feet repair tool. Now you can find these on eBay or AliExpress. It's a rather simple assembly and it allows you to vertically mill a flat recess into the dial to accommodate the plate of the dial feet replacements. And you can notice that the mill blade has a sharp point which can be centered over the point on the dial where the dial feet had broken away. Now I have an old scrap dial here that I'll be using today for demonstrating these methods. I've placed the dial into a watch movement holder and I can touch the mill to the dial and I can turn it whilst providing a little bit of downwards pressure, and as you can see the mill is cutting into the dial. Now I want a recess of around about 0.1 of a millimeter. It doesn't need to be too deep. So it cuts very well and I'm pleased with the result. And the tool came with some accessories too. It came with a couple of different sized movement holders. These are used for securing the dials before milling. And we have some adhesive. Now it does say Swiss quality on the label, but I have absolutely no idea what type of adhesive this is. I won't be using it. I think 5-minute epoxy will do the job quite well enough. So this will go in the bin. And there's also a watchmaker's oiler included, and this is useful for applying the adhesive. Also contained in the kit were some vials of dial feet, and there are 5 different sizes here, and these can go in with the collection that I already have. And as you can see, the replacement dial foot fits perfectly within the recess that we've milled out. The diameter of the plate and the recess provides for a decent amount of bonding surface, and this will make for a nice, strong repair once the epoxy has been applied and cured. Okay, so let's explore the soldering method and take a look at our watch dial feet soldering machine. Now, as mentioned, this was purchased on eBay from a really nice guy. He claims to be a watch repairer and an electrical engineer. He's based in Hungary. Now, we exchanged a few messages and I've mentioned to him that I'll be featuring the unit on this channel. However, this is not a paid review. There is a link to his eBay store in the description of this video, as I know many people will message me asking for that info, but again, this is not a paid promotion and this is not an endorsement of his product. I must also mention that these machines are new to me. I have never used one before, so take from that what you will, but I will show you some of my journey in learning how to use it. Now, the unit arrived fairly quickly after ordering and he did provide a small care package. Now we have some solder paste. We've got some liquid flux. And we have several different gauges of copper wire. And we have a few spare parts. The unit itself has a copper tip fitted to the probe, and we have a spare one. And there's a protective cover. Now onto the main body of the tool, and unfortunately I encountered a little bit of a manufacturing defect. I mean, it's not too serious. I was a little bit disappointed, but it looks like it will be an easy fix, so no problems at all. Now the arm for holding the wire in place prior to soldering is secured with, well, I suppose, a nut, and this nut was not tightened down correctly and had possibly come loose in shipping. Now it's rattling around inside the chassis. now, so I'm going to dismantle it and resecure it. But this is the main place where the dial is secured. It's made of brass, and the brass screw runs all the way through the center of the dial in order to secure it. A thin piece of what looks like leather prevents the dial face from contacting the brass plate. Now, on the front of the unit we have a pot which can be turned to adjust the deliverable voltage, and there's a voltage display, and there's a power switch. At the rear we have an AC plug socket and the connector socket for the probe. Now, the unit is made from a metal box which is strong enough and has what seems to be a durable coating. The front portion of the top is covered in felt, perhaps for insulation. The holding mechanism for the wire consists of a shaft which should be secured to this chassis, although I'm yet to fix that, and attached to this shaft is an adjustable crocodile clip, and this is used to hold the wire in position prior to soldering. Now, wing nut can be used to loosen or tighten the crocodile clip in order to adjust its position. Now let's open this up and fix the shaft. The unit's held together with 4 screws, 2 on each side, and once loosened, I can lift away the lid from the chassis and reveal the internal components. Now, not an expert, but the cabling does look quite clean and well organized or managed. It looks fairly well constructed. The connectors all look as if they've been well crimped. The centerpiece, it's a 230 volt to 6 volt transformer. No doubt that this means the unit may not be effective with a 110 volt supply in the US, but maybe more knowledgeable people can confirm this in the comments below. Anyway, I suppose I should retrieve my nut and, well, put this post back together, and then we can get down to learning how this unit operates. Before I start, I want to just make sure that it's not going to kill me just as soon as I touch it. So I'm going to check around the chassis and make sure that none of the exposed metal will cause me to fly across the room when I switch it on. Okay, now I'm pretty confident that the machine is safe to touch. I'm going to give it a good go, and as mentioned, I have this scrap dial to practice with. Now I'll place the dial on top of the brass plate with the lever pad acting as a shield, and I can use the screw to secure the dial in place. And I'm going to start with this 1mm gauge wire. This seems to be copper wire and it's plated with silver, and I guess that helps with thermal conductivity. To prepare the dial, I'm using a fiberglass scratch brush to remove any oxidization and provide a clean surface for the solder to adhere to. and I'm just filing the end of the wire to be flat. And now I can secure the wire with the crocodile clip and I can adjust the position. Now, naturally, if this was a real job rather than a practice, I would want to be very precise with the position of the wire. But in this case, I'm only really concerned about getting the tip of the wire to fully contact with the dial. Now I'm applying a little bit of liquid flux provided with the kit. And for some bizarre reason, the lever has decided to come alive and is now blocking the view. I do apologize for that. But I'm applying some of the provided solder paste. I'm not quite sure how much to use, but to start the experiment, I decided to be minimalist. Now I try touching the probe to the wire, and well, not a lot happens. But I realize in a moment that I do need to apply a little bit of downwards pressure on the wire in order to make a good contact with the dial. As you can see here, the wire is moving when I touch it. It's close, but the wire is not contacting the dial firmly enough. So I've added a little bit more solder paste and I've adjusted the camera position. But just out of shot, I'm now using a little bit of downwards pressure on the crocodile clip to help the wire stay in contact with the dial whilst I offer up the probe. Now later on I change this technique again and I start using insulated tweezers, but we'll get to that. Now I'm being very conservative and I'm just really tickling the wire with the probe for very short periods. Obviously, if the probe stays in contact for too long, the wire may melt and basically act as a fuse, but I can see the heat being generated. It's affecting my solder paste. Now I find that when learning a new process, it's important to be cautious, but sometimes it's good to ramp up in order to test limitations, and later on I'll be trying to touch the wire for longer periods in order to gauge the best results. And but for now, I'm just content with a slow and steady approach. Now cleaning away the excess, I can see that we have, well, failed. Time to clean up and try again. But first, I want to see if the dial's actually been affected by the heat. Sorry I didn't get this fully in shot. But it does seem that the dial has not been burned, so I'll continue on and perhaps be a little bit less conservative this time with my next attempt. Oh, and I'm not sure about this lever really. The dial had actually stuck to it a little bit. I don't think that's a good thing. Now I'm wondering at this stage if Teflon baking paper might be a better option. I haven't got any here at the moment, so I can't try it just now. We'll just carry on regardless, but yeah, that's something to think about for the future. Okay, I failed to mention it before, but the voltage I set with my last attempt was 140 volts, and for this round I'm going to try 170 volts. And already I can see the higher voltage is much more effective in melting the solder. And in fact, the wire does feel like it is strongly attached. Now looking at the dial face, I'm also pleased to see that there are no burn marks. Let's clean off the residue and inspect the joint further. And well, I mean, that seems strong enough. But maybe I've used a little bit too much solder. The build-up might be just a little bit too much. If this was a real repair job, I suspect that the dial may not sit flush with the movement as a result. But it's still an encouraging start. Now, I tried again several times with varying levels of success. I won't bore you with all those attempts as the video will get too long, but here are some of my results. Now, in short, I ended up switching to Amtech solder paste, and this is a product that I've been using for a long time, and I've usually had quite excellent results with it, and I felt that I was getting much better results in this case as well. So here was my first attempt using the 1mm wire, And we got a great result, although I did use too much solder, but the joint was actually very strong. Now, as an experiment, I tried soldering the pre-made dial feet, and that really didn't go well at all. But it was worth a try. Just for kicks, here I attempted using my jewelry pulse arc welder, and that also didn't go too well. Brass cannot really be welded, and it just blew a crater. The solder did melt, but the joint was not strong at all. Still, it was worth a try. The next 3 attempts are getting more encouraging. Now, I'm experimenting with the amount of solder to use and the different voltage settings with varying results. I managed to melt the wire on a couple of occasions, but I was starting to actually get the hang of it. Now, one important thing to remember is not to apply too much downwards pressure, as this will happen. As you can see, I've switched to using insulated tweezers, but if too much heat builds up, well, the wire will start to melt. But as you can see, the results are getting better. However, now I'm not using enough solder, and the joints are, well, they're not really strong enough as a result. But after all this experimenting, I have managed to find a compromise of the minimum amount of solder needed for a reasonably strong joint. So let's move on to a clean dial, and I'll share my findings. Now I'm going to fit 2 dial feet, one soldered and one glued, and we'll compare the 2 of them. Now first mill the recess for the pre-made dial feet. And now I can set up the dial for soldering. So I'm applying some of the Amtech paste here, and I know it does look like a lot, but a lot of it is flux, and once melted, I've found that this is a reasonably good sized application. So 3 or 4 bursts of around a second or so each seems to melt the solder well enough to make a good joint. And apologies for not showing the voltage screen, but I found that the best setting for this gauge of wire, that is 0.8mm, to be hovering just around 150 volts-ish. And when I clean that up, you can see there's a nice satisfying glob of solder. But I do have a little trick up my sleeve, and we shall get to that soon. But let's first fix the pre-made dial foot for a comparison. And I'm using my tweezers here to roughen up the surface of the recess. And I'll do the same to the plate on the dial foot. I'll mix up a small amount of 5-minute epoxy here. And I can place the dial foot in position. And now that it is dry, here's a comparison shot of the 2 different repairs. And here's a little trick. Now I'm using a milling tool, which is made by Horatech, to remove some of the excess solder, which will allow the dial to sit flush with the movement. With a real-world repair, I would leave as much solder as I can get away with, as long as the dial is flush with the movement, but I'm sure you will agree that this leaves a much more professional finish and the joint still feels strong. So what about our Seiko dial? Well, as you can see, the manufacturer has already used quite a bit of adhesive in order to secure the individual dial decorations, the dial chapters, numbers, etc. And so I'm not really entirely comfortable using heat in this case. I think the more appropriate method for this particular dial would be to use the pre-made dial feet and use epoxy to secure them. So I'll start by milling the recesses. The center point of the milling tool really does make it easy to mill in the exact location of the broken dial foot. And I can choose 2 dial feet with the correct diameter to fit the movement. I shall score the milled recesses to provide a key for the epoxy, and I'll do the same for the dial feet. And now I can apply a small amount of epoxy to each of the recesses, and I'll place the dial feet in position. And once the epoxy has cured, I can use my little Horrortech mill to remove the excess. These dial feet, well, they're a little bit too long, so I do need to shorten them. The filing left a small burr, so I can use my steel tweezers to burnish those. And a little flick with the file breaks the burr off. And now I can reassemble. And that's it, my first adventure with a watch dial feet soldering machine. In my opinion, it would be risky to have used this for the Seiko repair due to the amount of adhesive on the back of the dial. I was concerned that damage might occur, but the soldering machine seems to do a good job once you've practiced with it for a while. But in conclusion, will the soldering machine be my first choice for repairing dial feet in the future? Well, on a personal level, I'm going to be honest, and I'll say that I prefer the pre-made dial feet and epoxy method. Now, I mean, that's not to say that the machine is bad. Absolutely not. It does the job absolutely fine, but the finish on many watch dials can be very sensitive and extreme care must be taken. And for me, the risk of heat damage may be too great because even a 1% risk of damage to somebody's property is 1% risk too much. And especially because any damage to the finish of a watch dial can be extremely obvious. I mean, it's perhaps the most visual aspect of the watch, and the kind of damage that could occur from heat may well be irrecoverable. But if I was 100% confident that no damage would occur, I would definitely use this machine again. But for most scenarios, I feel the risk for me is too great. But that's just my opinion. What are your thoughts on this? Am I wrong? I'm really interested to know your thoughts, so please share them in the comments below. But that's it from me for this video. Big thanks to my patrons who helped to make this content possible. If you did like this content, then kindly help spread the word with the share links below. If you're not already subscribed, then feel free to do so now. It's free, and if you click the bell, you'll be notified whenever I publish new content. Okay, I'll see you in the next one. Take care.